Let's do a little statistics. The block of numbers you see here are the ages of the presidents of the United States at their first inaugurations. We had the youngest one at 42. The oldest one is actually our current one at 70. And this is all nice. It's a big block of numbers, and I don't get a whole lot of information from looking at that other than they're between 42 and 70. There's a lot in between. One thing that can help make a little bit more sense out of data like this is a frequency distribution. So we're going to make one of those for this data. The way a frequency distribution works is I'm going to put my data on the left, which is age here, and on the right, I'm going to put frequencies, which is just counts. I'm going to count how many people were that age. If I list every single age over here on the list and just count all the 42s and then all the 43s and then all the 44s, it doesn't give me a whole lot more information than I can get just from looking at the list. So I'm going to group my frequencies together. When we do that, we got to make sure the categories are all the same size and they don't overlap. I'm going to start at 40. And let's see, 40 to 45, so, if we count by fives, that seems like a pretty normal way to go. But maybe I want to start my next category at 45. If I put 45 over here, and I have 45 over there, I actually don't have anybody who's 45, but if there were somebody who was 45, they belong to two different categories. That kind of doesn't make sense. We want to divide them up so that everybody's only in one category. So instead, I'm going to go to 44. And then I want all my categories to be the same size. So I got 40, 41, 42, 43, 44. That's really scary up that close. So I want 45, 46, 47, 48, 49 for my next one. And all the rest, once we have the first couple set up, everything else falls out from there. So I'm going to have 50 to 54, 54 to 59, 60 to 64, 64 to 69, and it almost fits. 70 to 74. I do have to put that last one on there because there is somebody who's 70. Now, it's a matter of counting. I'm going to count all the people who are in the 40 to 44 category. Well, here they are. There's a 42 and a 43. There's two of them. 45 to 49. 1, 2, 3, 4, 5, 6 in that category. And so on all the way down. This is like one of those cooking shows. I have one over here that's already done. Taking it out of the oven miraculously. One in the 70 to 74 category. There's my frequency distribution. Quick check. If I add up the frequencies, I should get the number of data points that I have. We've had 45 presidents, so they should all add up to 45. And they do. There's my frequency distribution. It might be nice to make a graph out of these. The graph that comes from a frequency distribution is a histogram. The histogram has a vertical axis and a horizontal axis, as many graphs do. The horizontal axis is a number line. The horizontal axis is going to contain our age data, and it's a number line. So I'm not going to put 40 to 44 on a number line because that's not how a number line works. I am, however, going to do this. I'm not going to start until 40 because I'd have a big, long stretch of nothing if I did that. So the way we can decide what ages we're going to put on our horizontal axis is go down the left-hand part of each category. So I'm going to put 40 and 45 and 50 and so on. Hopefully these are about the same distance apart. So that my bars all end up the same width. On the vertical axis, I'm going to put the frequencies, or the counts. I'm going to look at my frequencies here and notice the lowest one is 1 and the highest one is 13. I think I'm going to count by 2s. You can count by 1s if you want. I probably wouldn't divide it up much bigger than that. So 8, 10, 12, 14. I'm going to draw a rectangle above each age range that's the height of its frequency. So the 40 to 45 range, or 40 to 44, 44 to less than 45, has 2 people in it. So I'm going to draw a rectangle here whose height is 2. It goes up to the 2. Next one, 45 to 49, 6. So I'm going to draw up to 6. The next 2 categories are both 13, so that's up here. 2 for the price of 1 there. They're the same height. That's coincidence. Then I have a 7, which is a little bit more than 6. Should be a little bit taller than the 6. Then a 3. And the last one has a height of 1. When we look at this, we're going to notice right away that there's a whole lot of people in the 50 to 60 age range. In fact, if we kind of round off the corners and zoom way out and look at the overall shape of this distribution, it's kind of bell curve shaped. It's kind of normal distribution shaped. Characteristic of normal distribution or a bell curve is that there are a whole lot of observations near the middle and fewer at the extreme. So we've had a whole lot of presidents in kind of the medium age range, 50 to 60, with fewer who are older than that and fewer who are younger than that. If we look at our block of numbers, that seems to reflect what we suspected. There's a whole bunch in the 50s there. Well, now we have a frequency distribution and we have a histogram. Let's find some statistics. Let's calculate measures of central tendency. The mean of a group of data is, to find the mean, I'm going to add up all of the data values and divide by how many I have. The number of values. So I'm going to take these 45 numbers up here, add them all up, and once again, like a baking show, I did that already. So when you add 42 plus 43 plus 46 plus 46 all the way on down the line, you get 2,485. I'm going to divide by the number of values, 45 presidents, and I get a mean age of 55.2, and that's in years. That's the mean, kind of the classic, what we think of as average. Another way to look at average is the median, which is literally the middle value from a list of data. So I want the middle one. Well, it's nice and organized in columns here, so let's see. If I cross out the highest column and the lowest column, the median isn't there. It's not in the next two, not in the next two. And I'm just working my way into the middle. The median is in this middle column, and it'll be the middle value in the middle column, which is 55. So my median is 55. The median and the mean don't have to be the same value. It's okay if they are, but it's also okay if they're not. You might have noticed the mean 55.2. There was nobody who listed their age as 55.2, and that's okay too. A lot of times the mean is not an actual data value. It's just where the middle of the data is. And let's look at the mode. The mode is the value that occurs most frequently. Well, you might suspect it's going to be 55, but if I look at my list, there's 4 55s, but there's actually 5 54s. And also 5 57s. So we're going to call this data bimodal. It has 2 modes, 54 and 57.